In 1984, IBM released the awesome 5170 AT and set the new standard for all the clone makers to clone. But it has one big flaw, almost as big as its case. While the clones kept upgrading their machines with faster 286s, the original AT never got faster than 8 MHz. So in this video we are going to restore and overclock a Type 3 5170. This video is sponsored by PCB. More on this later. Thank you PCB for supporting this channel. At the back here, this machine has a serial and parallel port, some sort of graphics card and a mystery card. The machine needs a proper wash, but otherwise it looks to be in a really nice condition. So let's pull that lid off. See what we'll find inside. Well, we've got dust in here and a Type 2 drive and what looks to be the original diskette drive and a blank. It's actually not that bad. It's mostly just dusty on the front here. Inside the machine it's actually quite clean. So first we have the original controller here for the hard drive and the floppy drive. Let's get that card out. There were two types of these controllers, and apparently this machine has the first generation. You can tell because it's an extremely large card. Next up we have the serial and parallel card. These tantalums can short and prevent the system to boot. This card is gonna come in handy later in this project. If all goes well, this IBM is going to end up with Windows and will need somewhere to connect the mouse. Next we have the mystery card. Okay, I'm reading from a forum thread online here. Apparently this is a 5250 emulation card. Apparently this machine was used as a terminal for either a System 36, 38 or AS400. I don't have any of those unfortunately. Well, not yet. If I ever find one, I'll make room for it. This is a regular black and white parallel card. Not much to say about this card, except that it's extremely clean, so the dust never found its way inside the machine. To get that hard drive out, we need to remove this large bracket. The large bracket also has this small piece. We're gonna need it later, because it's used to install in this position here, when you install a second drive. So now we can pull that Type 2 drive out and disconnect all the cables at the back. I don't quite remember how large this huge drive is. And this guy here is a Seagate model ST4026 and manufactured for IBM in New York. So definitely the original hard drive. I'm a complete sucker for these large MFM drives, so I hope it works. Next up we have the floppy drive. It's held in place with two of these small clamps. This drive hasn't gone yellow, but I think this cover has yellowed slightly. But we're not going to need it for this project anyways, because we're going to install a second drive. This drive is a bit dustier than the cards inside the machine, but this should be easy to blow out with some compressed air. The blank is held in place with these two flathead screws. And then we have a second blank here. And if you were crazy rich back in the day, you could install a second MFM drive in this position. Hey, that sounds like a good dream machine build for me. Two massive MFM drives in an AT. Well, if I can ever find a spare, that's what we'll do. I'm gonna remove the LED panel too, because I'm gonna give this case a wash. That means removing the speaker too. That is hidden away inside here. Being an AT, it obviously has AT power connectors. This looks a bit dodgy. Motherboard is held in place with two screws and a bunch of extremely annoying plastic clips. I hate those guys. But that is also the only thing to hate about the AT. Otherwise, this is an awesome machine. Slow but awesome. And apparently those annoying plastic clips decided not to give me any trouble today. So that's nice for a change. Inside here we've got some dust, but no rust. And apparently I did remember to remove the battery. And now we can remove the power supply. And we've got a date here, 1985. I was expecting a later date actually. because we have restored one of these that ran at 6 MHz, and that machine was manufactured in 1986. So that means they kept selling the 6 MHz machine after they had introduced the 8 MHz machine. Now let's find out why this cable here is loose. Check for things that explode. This power supply is put together with T20 security screws. If you don't have a security bit, you can always use a Dremel. Okay, I think that was the last screw. And the usual disclaimer, please don't mess around inside power supplies. They may be charged with high voltages inside. That being said, this power supply has not been turned on for a very long time. Well, that's a nice blue PCB. Haven't seen one of these in a power supply before. Ah, it's one of these guys. This power supply is not identical, but quite similar to the power supply in the 6 MHz AT that we have restored before. And these power supplies have the safety caps all the way down here at the bottom, underneath this PCB and behind these large caps. So we need to do some more disassembly to check for refills. Now this is very strange. The cable coming out of the power supply is not secured. I guess they ran out of parts when they manufactured this power supply. Now let's remove this nice blue PCB. They are easy to remove, but a pain to reinstall. Actually, we don't need to completely remove it. You may not be able to see this on camera, but these guys down here are not refus. Those are some yellow guys. Probably safe to use. Okay, my memory seems correct. That is an 8 MHz 286. So definitely a Type 3 board. Okay, the case has been washed in warm soapy water and left to dry. Everything else has been dry cleaned. Time for a test. Let's start with a simple test. We've got power keyboard, graphics card and display, speaker and power LED. Let's flip that switch and see if this machine works. Okay, fan spun up in the power supply. We've got a couple of beeps. Diskette error, system options not set, and diskette error. That looks pretty good. In that case, let's connect that huge controller card. Let's add some drives next. So I'm going to connect the original drive as drive B. As drive A, I'm going to use this HP branded ALPS drive. Obviously not period correct. This drive was made in 1998. But the color on the faceplate isn't too far off from the original color of this IBM. So I thought we'd give it a try. The edge connector obviously doesn't fit the IDC connector on this drive. Thanks to my sponsor, we've got plenty of these. We have built these in another video. I'll put a link to where you can find these. So it's just an adapter from edge connector to IDC. We're also going to need one of these. And these can be found on Amazon for cheap. That's just a simple adapter. Let's start with a cleaning disc and see if the drive spins up. Wow, that is a quiet drive. It must be damped inside. It's dead silent. Doesn't make the usual clunky noises. Okay, let's switch the power on and see if it spins up. Yes, it does. Awesome. I'll run that cleaning disc a few times before we try to boot. And next up we have our massive 20 meg drive. Okay, we're all set. Let's run gsetup to access the BIOS settings. Let's hit F1. Well, that didn't work. Well, this drive is untested. So let's use another drive. And try again. Okay, I can hear the drive reading and starting MS-DOS. Now let's run gsetup. Okay, so we have a bad drive. Well, that kind of sucks. Let's go to setup. Well, that's an interesting date. What's up with that date? That is silly. I'm just gonna set something random here because we don't have a battery yet. Is this machine year 2000 compliant? I think it is. Okay, drive A is not defined. So drive A is 1.44 meg drive. This may actually not work. I haven't checked what version of the BIOS we have. Some early BIOSes don't have full support for 1.44 meg drives, but that doesn't matter because we're not going to use this BIOS anyways. So drive B is 1.2 meg drive, and this is a type 2 drive. Base memory is 512K, so we are going to need to upgrade this machine later. We're obviously using the 5151 display at the moment. That is going to have to change later too. Okay, I think we're all good. Let's save and see if we can access the floppy drive. Yeah, this machine seems to be year 2000 compliant. Let's read drive B. Yes, works. Awesome. Now, how about that hard drive? Yes! Now let's see if it will boot on the hard drive. And it doesn't, so we have a messed up installation. Well, in that case, let's boot to SpinRite 5. Too bad about that matching diskette drive. I guess we could try to fix it. Okay, it passed all the tests. And the interleave is set to 3 to 1. Next we can test the drive for optimal interleave. I'm obviously skipping ahead here, but the test is done. And the drive's performance may improve by 50% with interleave 2 to 1. That was kind of expected. So let's change it and continue. Okay, benchmarks are running. And hard drive sounds good. Okay, let's move on to SpeedStore 6.5. I decided to skip ahead here a bit. I did a low-level format of the hard drive and installed DOS622. And this drive seems to be working fine, since I obviously intend to overclock this machine. We need to swap that BIOS. Unfortunately, this socket is so close to this can. It's really hard to use the proper tool to pull these guys out. But I'll just be careful and we should be fine. There are many different BIOSes to choose from that obviously aren't intended for it. I'm gonna go with an Army BIOS from 1990. Okay, let's flip that switch and see if this works. I think it does. ROM BIOS 1989, American Megatrends. System configuration 286. 1.44 meg drive A, 1.2 meg drive B, monochrome display, and the date is from 1990. RAM is correct too at 512K, and a hard disk type 2. So that was a bit easier than I thought. Yeah, this is awesome. Sometimes things just work. Okay, let's run some benchmarks. Just to check that everything works. Okay, that's a bit odd. Apparently this 8 MHz AT performs like a 9 MHz AT. Well, that's really odd. So, not sure what to make of this. We haven't changed anything except for the BIOS. By the way, we swapped that BIOS because the original IBM BIOS checks for overclocking and holds the system if it detects the faster crystal. This crystal is a bit tricky to get off the board. It sits in the special socket here. So 16 MHz divided by 2 gives us 8 MHz. The slowest crystal I have is 22.4 MHz. Oh, that doesn't fit in the socket. Crap. Those legs are too thin. Well, that sucks. Okay, I found some beefy diodes that will fit the sockets. Well, I cut the legs of that diode and soldered the legs to the crystal. Really bodgy, but I think this will work. I guess the only way to find out is to test it. Well, I think it fits. Well, we're not gonna get far with that original CPU. Okay, unfortunately I ran into a big problem here. I didn't have a slow enough crystal and I only prepared with a 10 MHz CPU. So I went through my stuff and found a 12 MHz CPU. But this guy is in wrong form factor. And I also found a spare socket for another project. So maybe we can board some more. Well, I don't want to replace that original socket on the motherboard, but I think we might be able to install this socket into the original socket. Well, it certainly fits. This socket is obviously not intended to be installed into another socket, but who knows, perhaps this will work. Well, this is quite a bit more than I was gonna go for. But hey, fingers crossed. Let's see if it works. Hard drive spun up. We're getting nothing on the screen. Oh crap. Well, I don't know if my dodgy crystal works. So let's pull that crystal off the board and do a test with the original crystal. And it posts. So that socket contraption actually works, but that crystal is too fast for this board. Ah, that sucks. Okay, maybe we just got lucky. I found a 20 MHz crystal on one of my network cards. So let's borrow it and see if we can make the machine run at 10 MHz. Okay, I soldered the 2 pins from the diode to this crystal instead. Man, that is one ugly installation. Okay, fingers crossed. Let's see if we got lucky with that network card. Oh! We got something on the screen. Okay, let's try to boot with the hard drive connected. Okay, I think it's booting. Yes, it did boot. Awesome. Let's run those benchmarks. Okay, now it thinks it performs like an 11 MHz AT. So again, 1 MHz off. Well, 1.25 to be more specific. So we're running this AT at 10 MHz. That is awesome. So I guess we need to check if it's stable. Let's reassemble this machine before we do the stress test. The chassis cleaned up really nicely. So this machine has been stored really well. By the way, the date on the chassis is older than the dates on the chip of the motherboard. So that date is probably not when this machine was assembled. It's probably from when the chassis was made. Well, we actually still have one more problem to solve here. Drives in this machine are installed with these rails here. They're pretty standard and they used to be really easy to find. But nowadays they are getting increasingly hard to find. There were a few sets available on eBay, but they were silly expensive. So, to install our 3.5-inch diskette drive, I ordered these from the sponsor of this video, PCB. So, these are actually designed by Agent Black quite a few years back. So, thanks if you're watching this. Yeah, these look nice. These look really good. They don't really look printed. I'm saving up for a printer, but maybe I shouldn't. I put a link to where I found this project in the description below. Now let's try them out. Yeah, stuff like this is getting harder and harder to find on eBay. So projects like this are extremely useful. Okay, let's see if it will fit. And of course it does. It fits perfectly. Too bad I couldn't color match that 3.5-inch diskette drive, but I'll keep looking for a matching drive. Or perhaps we'll repair this guy here. The color isn't identical, but it's not too far off. Yeah, I think we're gonna repair this one in a future video. And of course, Murphy's Law never fails. I used the wrong bloody screw holes. There we go, that's better. Oh, we forgot to include the serial and parallel card in the tests. Let's hope it doesn't have any shorted tantalums. Okay, let's put that lid back on. I skipped ahead here a bit because I did a thorough disassembly and reassembly In the 5170 Type 2 video. Wow, this thing is huge! That PS2 display on top looks like a miniature on top of that massive IBM. It's stable enough to place on Monkey Island, but not much more. I was aiming for 9 MHz, maybe 10 in this video, because I know these boards have issues with faster speeds. However, I think there is a fix to get these boards faster. I have actually already ordered some components to make an attempt to go faster, but they are coming in with slow shipping from China. If you're watching this in the future, there will be a link on the screen shortly to an attempt to go beyond 10 MHz. If you're watching this fresh, hit the bell icon below and set it to all. Meanwhile, check out this restoration video about the awesome IBM PS2 P70. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up and a comment. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, I'll see you next week.